So students, welcome back to this channel in which we teach about how to make math fun. And today we're going to continue our class 12 series, and today we're going to be starting a new chapter. It's going to be inverse trigonometric functions, ITF in short. Okay? So now what are these? What are inverse trigonometric functions? So what is a function to begin with? A function is a mathematical tool that takes an input and does something to it and gives us an output. For example, we have a function here. I have already learned about this in 11th, at least I would assume so. Let's say a function that takes any input, x for example, then turns it into x square. This is what this function does. Okay, this is a mathematical tool that takes an input, does something to it, and gives us an output, of which in this case is x squared. The same way, we have a special type of functions called trigonometric functions. You guys have learned about them already. That there's first of all there are 6 types of trigonometric functions. The first one is sine. It takes an input, which is an angle, and gives us an output. So let's say the sine function takes an input of pi over 3 radians, and you know what is the output of this? This is going to be root over 3 over 2. This is how trigonometric functions work. I'll assume that you guys already know what functions are and what is the domain and range of function. But don't worry if you don't have any idea of that. I'll go through that again. So the domain is a list of possible inputs that the function can take. So for example, a trigonometric function can take any real input and turn it into something. And this is a basically very brief overview of what domain and range are. And range is a list of output that functions can give us. The first two trigonometric functions, sine and cos, have a very interesting property that we're going to be talking about later in this video. But you guys right now know that what is a domain and a range of a function. Domain is the list of input that a function can take, and range is a list of outputs that a function can give us. So for this sine function, domain is any real number. So dome of sine function belongs to the set of negative infinity to infinity. Okay. Now range. What is the range of sine function? Range of sine belongs to. Now this is the interesting property I was talking about. Both sine and cos function can take inputs ranging from anywhere between negative infinity and positive infinity. But their output always stays inside of a certain range, inside of a well-defined range, and that range begins from -1 and ends in +1. You know what these cards of brackets mean. These first brackets mean that the domain of sine does not can get to this point, but won't actually touch infinity, because infinity is not a defined number. So Of course, if the number is not defined, how can I even approach that? But in the series of outputs, both -1 and +1 are well defined real numbers. So of course we can approach that. So I think that idea is clear right now. Now this was all about trigonometric functions, but in this chapter we are not going to be learning about trigonometric functions. What we are going to be learning about is inverse trigonometric functions, functions which are inverse to trigonometric functions. Now, what are inverse functions? Inverse functions is a function that works in the opposite direction of a regular function. Let's say we have a function of x here that gives us x square. Now, what does inverse function do is, inverse function takes the output of the original function and as input, and gives us as output what the input of the original function was. So inverse functions are written this way. If the original function we had was f of x, the inverse of this function would be f to the -1 of x, f to the -1 of x square, because in this case we are taking x square as its input, and you will be given x. So this works in the opposite direction of the original function. This is what inverse functions are do. This is what inverse functions do. Now, this was about a function that gives us output x square. Now, what do you think would happen to trigonometric functions? This is the input of a trigonometric function, and this is the output of a trigonometric function. So, what do you think would happen if there exists an inverse function that of this trigonometric function? What do you think that function would do? Don't you think that that function is going to take this value root over 3 as input, which is the output of our original function, and give us back this value, this which is the input of our original function, and that is going to be the output of the inverse function of this one. So this is what this is going to become is. I mean, what this means is, this implies that we have a let's say we have an inverse function of this sine function, sine inverse, and it takes an input of root 3 over 2. I've told you guys that inverse functions takes the output of the original function and gives us the input of the original function, and it would give us pi over 3. Okay, this was a very general idea of what inverse functions are and how they work and how they're defined. Now, this is not completely true, because trigonometric functions, I mean, if I had any polynomial function, for example, this is a polynomial function over here, this is x square. If I said that there was a inverse function of this one, f inverse, which takes x square as input and gives us x, then that would have been correct for all the time, but and that is probably would have been the only possible inverse function of this one. But saying that sine inverse of root 3 over 2 gives us one output, and that is pi over 3, is fundamentally wrong. Yes, pi over 3 is definitely a possible solution to this possible output of this function, but this is not the only solution. And the reason that is, the first two trigonometric functions, sine and cos, are cyclic functions. Let's say we have a graph here of sine function. The y direction, x direction represents x, values of x, and y direction represents values of sine x. So this would look something like this. It's a cyclic function. So values just keep appearing and reappearing. Okay, so let's say onto this point. This is the point where the value of x is pi over 3. and the value of y, I don't know if you can see it right here. Let me do it here actually. X sine of x. Okay. Now let's say on this point the value of x is pi over 3 and the value of y is root over 3 over 2. Okay. So if we take an inverse function of sine and give it this input pi over 3, it would definitely give us this. Sorry, if we give it this input root 3 over 2, then this would definitely give us an output pi over 3. But pi over 3 is not the only value of x for which value of sine x is root 3 over 2. You can see according to this graph, we have a point here as well. We don't know what the value of x in this point is yet, but it would, the value of y would also be root 3 over 2. Another point of this kind exists over here as well, another over here. So you can see that these values keep showing up and to infinite times, because this function is going to go up to infinite, because this x direction represents the possible values this function can take as inputs, and I've already told you guys that sine function and cosine function can take values up to infinity as their input, as an inputs. So this means that this saying that pi over 3 of the output is the only output of the sine inverse function if we give root 3 over 2 as its input. There are also infinite many possible answers of this. So we would have to give a general formula of possible answers of sine inverse of x. How would I do that? In 11th, we had a chapter called General Solution of Trigonometry, in which the relation between basically that chapter showed us how the cyclic nature of these trigonometric functions work. Value of if let's say the value of theta is x, then what is the value of theta? Sorry, let's say the value of sin theta is x. Then what would be the value of theta? Theta would be n times pi plus minus 1 to the n times theta. I mean, obviously, value-wise, these two sides would not be equal to each other. But when we apply a trigonometric function to that, a sine function to that, these two sides would be the same. That means that in this case, n belongs to the set of integers. So what does this mean is that the output of the sine x function keeps on repeating after a certain interval, and this is that interval. That interval is n pi plus minus 1 to the n times theta. Now we can go on and give any kind of natural number as inputs. Like for example, if we say n is 0, so we would have, let's say if n is 0, then this term would become 0 plus minus 1 to the 0 is 1 times theta. That will be theta. That will be just theta. Okay, and let's say if n was 1, this thing would become pi minus theta. For pi minus theta as well, the output would be the same as theta. So this is how trigonometric functions and inverse trigonometric functions work. So when you say that sine theta is equals x, and we want to uh, apply an inverse function to this output, sine inverse of x, just saying theta would not be sufficient. We would have to say that this would become n times pi plus minus 1 to the n times theta. Okay? Because this is the interval upon which the value of sine theta keeps on repeating. And for all of these values, the output of this function, sine inverse, so for all of these values of this angle, the output of the sine function would give us x. So when taking x as input of the sine inverse function and trying to find outputs of that, basically it's like asking for what values the value of sine theta is x. The answer to that would be that for all of these values, the output of sine theta is gonna be x for all of these values of theta. Okay, this was the introduction to inverse trigonometric functions. In the next video, we're gonna be talking about how this works again. It works for cosine function and all the other functions out there as well. But I think this is how I end this session. So if you guys have any doubts regarding anything I have taught you guys today, please make sure to let me know that in the comment section. I'll try to resolve your doubts. Until then, keep learning.